So this is page 525, problem 72. We need to prove such an equation is identity. Tangent to the fourth power equal to secant square of z minus the cosecant square of z and plus cosecant square of z times the cosine square of z divided by cotangent square of z. So definitely the right side is much more complicated. So we begin with the right side. Now tell me what should be my first step. So definitely you need to deal with the numerator, right? Then in the numerator, what should I do? You make an observation and you see this term and this term, they have the common factor, right? The cosecant square of z. So now let's try to fact this common factor in this second and third term. So we fact out this negative cosecant square of z. And inside the parenthesis, we have the 1 minus the cosine square of z. Now, 1 minus the cosine square of z equal to what? Sine square of z, right? By the fundamental identity, so you have the secant square of z minus the cosecant square of z times the sine square of z. Then tell me what is the cosecant square of z times the sine square of z? What? Right? By the one of the reciprocal identities, cosecant z is equal to 1 over sine of z. So this guy, together, they make 1. Okay, so we just got secant square of z minus 1 divided by cotangent square of z. And then tell me, what is the secant square of z minus 1? You need to memorize those identities. Okay, especially the Pythagorean identities. What is this? Tangent or cotangent square? Tangent square, right? See, we have the 1 plus the tangent square of z equal to secant square of z. So secant square of z minus 1, you got the tangent square of z. So this guy is equal to tangent square of z. You should always keep the other side in your mind as the goal. So we need to get the tangent to the fourth power of z, right? So now here we have the tangent square of z in the numerator. and denominator is cotangent, so we need to convert this cotangent to tangent by using the reciprocal identity. So this guy is equal to 1 over the tangent square of z. And then you flip this to the top, right? So finally, you get tangent to the fourth power of z, okay, of z, and this is equal to the left side, okay, actually, L, and then done. Hard, and a little bit, right? But in the fourth step, you need to make observations of what you want to deal with. So here, you find the point. You find the point you can get it into. So these two terms have the common factor. So you find this out, and then you use the fundamental identity, and then you use the reciprocal identity, and then you use the one of the Pythagorean identities, and then use this reciprocal identity, and then you arrive at the left side. Now let's look at the 78. So problem, okay, it's on the page 525, problem 78. We need to prove this equation is an identity. So 1, the square of the 1 plus the cotangent alpha. And sometimes we need to work on the both sides. So now let's first deal with the left side. So for this part, we expand the square of this binomial, then we get the 1 plus 2 times cotangent alpha and plus cotangent square alpha, and then minus the cotangent alpha. So this 2 times cotangent alpha cancel, then you get the 1 plus cotangent square alpha. All right? Then what is this? 1 plus cotangent square equal to what? Secant or cosecant square? Cosecant, right? So cosecant square of alpha. Okay, so now we just stop here for the left side, then let's work on the right side. So for the right side, you may use the product of the sum and the difference of 2 terms. You know, this a minus b times a plus b, right, is equal to a squared minus b squared. So you have the 1 squared minus the cosine square alpha. And this is the 1 minus the cosine square alpha. Then use the fundamental identity is equal to sine square alpha, right? Then use the reciprocal identity. This is just equal to cosecant square alpha. So by now, okay, by working on the both sides, you got left side is equal to right side. and then done. Now let's look at the 82. 1 minus the sine square beta times 1 plus the sine square beta is equal to 2 times cosine square beta minus the cosine to the 4th power of beta.